Hello, I'm very excited about this series that I'm about to start, which is all about Solitaire. Solitaire is a good model for learning about how we can model and develop a solution to a problem in Clojure. First of all, it's a limited domain, it's well known, but it still has a lot of choices that we can make in it. So it'll be a good way for us to explore those possibilities and those choices. So this is just the first of several parts that will touch on Solitaire and how we can use functional programming to model it. The first thing we need to do is talk about the domain. The domain of Solitaire is actually quite small and interesting, and I have to say, I wasn't going to do this, and then I decided I looked up the rules to Solitaire, and I was surprised. There actually are names for all of these places on the table. And it got me thinking because, that always happens to me, is I think I understand a domain, I understand the game, and I start coding and I start making all sorts of design decisions, and then I regret it because I get stuck. I finally open up a documentation about the domain, a book, something, I ask an expert, and I realize I really don't know anything about it. And that happens so many times. I make the same mistake over and over. So what I want to say is it's very important to read the documentation. Even if you think you understand the domain, it's part of your job as a software engineer to read the documentation, to become an expert to some degree in the domain that you are modeling. It's not enough to just solve the problem, to get a program working. These domains usually have a lot of thought behind them, a lot of prior experience. So the Solitaire has been played for hundreds of years, so there's probably a good knowledge about how the rules should work, names for things, how the cards should be laid out, that kind of thing. More than you can add to it, and probably more than you know as a casual player of the game. So that's the last time I'm going to say it. It's your job. You have to, if you want to be a professional, you have to read the docs and become somewhat of an expert. Okay, so let's get into it. First, let's talk about our domain. Solitaire is a game. You play it by yourself with a deck of 52 playing cards. The playing cards have a suit and a value. The values go from A, which is a 1, through numbers from 2 to 10, and then they have Jack, Queen, and King, often represented as J, Q, and K. There are 4 suits and 2 colors. When you're playing the game of Solitaire, there are 3 locations on the board. First one is called the foundations. The goal is to build foundations. They start empty, but they are stacks of face-up cards, all of the same suit in order. So the ace is first, then the 2, then the 3, all the way up to king. And when you get all 4 foundations built, because there are 4 suits, you have won the game. The stacks down below are called the Tableau, and there are 7 of them. They have an interesting property. They have both a face down and a face up part. The face down part is how it starts, and there's 1 face up, and you can build on the Tableau by alternating colors, but you go down in value. There's some interesting rules about those, but we'll get to those when we talk about how to make moves. Right now we're just trying to model all of the state of the game, not the transitions between different states. And so then the last thing is called the stock. The stock is it also has a face down and a face up, and it's where you're playing from primarily. You'll be flipping cards from here to the face up pile that can then be played in the tableau and the foundations. So I'm not going to talk about moves, but these are we need to be able to represent this very board, this very table in code, in Clojure. And so that's what we're going to work on first. There are many ways we could do it, and we're going to go over a lot of ways. This is an exploration. There's no way to say definitively, this is how it should be modeled. There are many trade-offs in all of the representations. And so this is going to be more of a path through that design space, because I'm trying to give you tools. I'm trying to fill up your toolbox with all sorts of different ways of modeling. When you're faced with a problem that you need to do data modeling for, you'll have all those tools available to you. And that's more important than knowing the one way that this should be modeled, because it doesn't exist. And it's going to be based on your experience and your intuition and your taste. But having more tools is better. So that's what we're going to get into right now. We're going to start data modeling.